everyone, and welcome. My name is Sandhya Simhan, and I'm the Director of Marketing at DeepLearning.AI. Welcome to our new event series, AI Access. It's a series of speaking events designed to feature directors of machine learning, product managers, and other AI practitioners in the field to share their thoughts on the most critical AI trends and topics, as well as a deep dive into real-world AI use cases. Earlier in January, OpenAI launched a neural network called DALL-E that creates images from text captions for a wide range of concepts, expressible in natural language. As impressive and useful as a tool that is, it is worth contemplating how AI will disrupt the design industry, which might be automated in the future and where designers will fit at that time. Today, we are excited to have Patrick Hebron, the Director of Machine Learning Intelligence Design at Adobe, join us to talk about integrating design and technical innovation in AI-first products. Patrick is a designer, software developer, teacher, and author. His work explores the intersection of machine learning, design tools, programming languages, and operating systems, and is specifically focused on the development of machine learning-enhanced digital design tools. He leads the machine intelligence design team within Adobe Design, focusing on designing new interfaces and interaction mechanisms for AI/ML functionality in Adobe's creative tools. He's the author of Machine Learning for Designers, published by O'Reilly Media, as well as articles including Rethinking Design Tools in the Age of Machine Learning and a Unified Tool for the Education of Humans and Machines. In this talk, Patrick will share insights from his experience developing AI-first products and offer a sneak peek into some of the ways AI will transform creative tools and workflows. A friendly reminder for our audience who have registered with the Slido ticket, while you're listening to Patrick's presentation, if you have any questions for him, log in to our Slido page to submit your questions or upvote others. You'll find the Slido access link in the reminder emails we sent you. And now, without further ado, let's welcome Patrick.
Thank you, Sandhya. And thanks everyone for joining us for this. Very excited to be here. Let me get my screen share going. Sandhya, I assume everyone can see. We'll hope so. Okay, well, Sandy's already taken care of some of my introduction, but this talk is called Integrating Design and Technical Innovation in AI-First Products. I'm Patrick Hebron. As Sandhya said, I lead the Machine Intelligence Design Group at Adobe. We're located within Adobe Design Organization. And our core charter is to try to identify opportunities for and then initiate and incubate either new features for existing products or entirely new products, all built around AI capabilities. So the team is organized as roughly half designers and half engineers in sort of the machine learning engineering side. We also work very closely with an embedded design researcher, as well as several additional who work on various aspects of these projects. And the rationale for this organization of the team is, of course, there's a very large and extraordinary research organization, as well as product teams and engineering teams across the company, and we collaborate very closely with them. The reason we try to compose the team in this way is because we feel like there's a real need for invention in design to happen sort of at the interface between the UI UX and the algorithmic level. And so when it comes to getting entirely new model architectures, we of course look to the research organization. But within our team, we think it's really important to be able to stand up models ourselves, retrain on new content areas, sometimes do some architectural transformations, and be able to create a really, really close iterative loop between the visual design, the interaction mechanisms, and the sort of true nature of the technology. So I'll talk, of course, a lot more about sort of how we think about this work and why we've approached it in this way. But I think sort of to get things going, short version of it is to say that these kinds of technologies can do very, very powerful, exciting things, which were not necessarily possible through existing tools, and also are very, very difficult to visualize in screen design. So we find that it's often necessary to actually engage the direct technology in the design work, and also to really get sort of the right intuition for the technology and really open our minds to what is possible through it. We think that we need to play a lot. So as I go forward, I think you'll see some of how we think about this process. My apologies in advance. I would like nothing more than to be able to show you what we're actually building, but Unfortunately, I can't show you unreleased products, so we'll sort of talk about it in terms of process and look at some aspects of things, but at the same time, we'll all have to wait in order to see some of this stuff. Okay, so I want to start with sort of a framing idea for how we approach looking at this work. Here, referring to Thomas Kuhn's famous The Structure of Scientific Revolutions and borrowing on this idea in a certain way. So, if we think about something like gunpowder, the operating principle for it is in fact quite simple, but the implications of this technology are astounding. Earth-shattering, world-changing in many, many ways. And when we look at the pure operating principle, which I guess could be more or less articulated as rapidly expanding a gas in a semi-enclosed space in order to launch a projectile, there's a huge divide between that and what happens with this technology. So the way I've organized this here is to say, we have the operating principle, just stated it, and so this is the mechanism that performs the key task, either in a new way or for the first time. In this case, that key task is the ability to launch a projectile. In many cases, this task is going to be inherited from a previous paradigm. In this case, bow and arrow being perhaps an inspiration for a gun. In other cases, I think the key task may be net new. That's not that often the case, but in the realm of AI, I think it actually has a higher tendency to be true. Going beyond this, we then of course have the direct impact. I think this tends to be foreseeable from the point of view of the operating principle and of the key task. In the case of guns and gunpowder, the direct impact is that it greatly increases the effect of an individual soldier. I think in sort of more general principle, this kind of direct impact is usually going to follow a similar shape of operating as a kind of force multiplier. What's much harder to see is the broader implications. These are, in a sense, kind of beyond an event horizon. We can try to extrapolate from that direct impact, sort of look for the force multiplier and try to project forward. But even so, it's often very difficult to see the network effects and how this is sort of amplified, right? So, arguably, this technology, this operating principle, leads to one of the most astounding implications of all, right? That it enabled the consolidation of power, things like colonialism, right? And all of that can be very, very difficult to see from where we start. So the question then is, when we look at AI, how do we start to extrapolate that and try to understand what these sort of direct implications are going to be, as well as the broader impact beyond that? I think it's a very hard thing to harness, but if we can do that, then we can begin to think about how to shape the technology in the direction that we hope to take it within a broader purpose, within a social domain. So the operating principle for backpropagation is, in a sense, straightforward. At the same time, fairly abstract. Now, I know that a lot of this audience is going to understand exactly what I'm talking about here. And for those who don't, I apologize for not having time to be able to sort of fully elaborate it. But the notion of backpropagation is really a very singular mechanism that at the same time has really fueled everything that's been possible through deep learning, and therefore kind of the modern phase of AI. It could be stated as a method for automating inductive processes that utilizes the chain rule in calculus to compute the gradient of a loss function with respect to its weights. So what does this all mean in sort of a social context, right? Well, we'll start by just looking at some of the key tasks, and here limiting that to the domain of AI as it relates to creative tools. So I'm not going to try to be exhaustive here, just going to look at sort of a few key tasks. And at this phase of the talk, I'm going to actually very deliberately try to hold myself back from stemming into talking about the implications and the broader impact, because I want to sort of look at it, in a sense, unemotionally at just the level of what the actual functionality is, what the capabilities and what these key tasks are. And then, of course, we'll try to extrapolate those a bit further. Okay, so like I said, just a select smattering. So first, image segmentation. All right, obviously an extremely simplified version of the architecture here, but roughly speaking, we take input of a real image, a photograph, into often a convolutional neural network or an elaboration thereof, and the output of the network be a label map, or another image where each pixel is an index representing what category of object is being depicted at that particular pixel in the input image. Here's one particular type of implementation of it, DeepLab. And so on the left, we have two photographs as inputs and their corresponding outputs. So we can see here that this particular pink is meant to indicate a person, and the green represents a bicycle, purple representing a dog, maroon representing cat. Okay, here we have something that is able to parse the semantics of an image. And we'll leave it at that stage for now. Going into a slightly different realm, we have generative networks. There's obviously a diversity of architectures here. I'm just going to talk about sort of two basic categories. So here we have a very simplified, of course, view or basic rendition of a generative adversarial network, or a GAN. And so there's two basic components here. We have the generator component and the discriminator component, or the forger and the forgery detector. The generator is going to take a random vector as input and generate a fake output, a fake image from that. Simultaneously, we have a collection of real images, and we're going to alternately feed these into the discriminator, which is going to try to perform a binary classification of whether the particular image that it's looking at is from the real data set or produced by the generator. In doing this, the task it's performing is this binary classification, but under the hood, in a sense, what needs to happen in order for the system to be capable of performing this is that it needs to build up a kind of understanding of the likelihoods of the patterns that occur in the real data set. As it gets better at this, the generator also has to get better at being able to produce these patterns, and so the two elevate one another. Now, the random vector here is, of course, an interesting property because what it means is that the generator is going to be able to produce entities that fall within kind of the general possibility space as presented by the real image data set. But at the same time, it's not going to really direct towards any particular output. A good example of this style of network would be StyleGAN2, which produces these incredibly accurate or realistic looking faces. But of course, every time we roll the dice, we get sort of just a completely different person without a great deal of control at this phase of the output. Now, of course, I'm sure many of you are familiar with this technology and are aware of ways of introducing greater control into the equation. But at sort of the level of raw functionality, that's what StyleGAN and similar networks offer. Okay, now we can start to introduce a bit of an architectural elaboration on top of this, which is the conditional GAN architecture. So here we have the same basic setup, but we've introduced sort of a piece of additional information, both coupled with the real image as well as with the fake. And so that could be one of a few different things, and we'll look at a few different variations of that. But as per the conditional notion, this is going to help to condition the generative and discriminative tasks in terms of sort of localizing the meaning of the generation. So in the form of big GAN, taking this sort of most literally, we have a label which distinguishes what category of entity the generator should produce. So big GAN is capable of 1,000 categories of objects. And while any particular generation within a category is going to be sort of random in the same sense that was true of StyleGAN, in this case, we can at least localize to which of those individual categories we want to generate outputs from. Next, we have a network like SPADE, where here the conditional input is a semantic map, much like the one created by the segmentation model that we saw a moment ago. And here we are stipulating what category of entity is going to exist at each pixel in the output. So we don't control sort of the exact nature of the texturing of the output, but we can control at this phase the overall composition of the image and what it contains. And finally, just to look at one more, we have CycleGAN, also a conditional network, where here we are able to take in an image of one category and translate that into a different domain. So we have the image of a horse, and we're going to output an image where that has been translated into a zebra, or a scene of a summer environment, translated into the domain of a winter environment. So, just as we are sort of in general with GANs learning kind of the statistical likelihoods of the patterns that exist within a particular sort of domain of interest, here we can also sort of understand what the absence of that domain looks like and elevate it, right? So we can sort of elevate the zebra-ness in an image that is otherwise of a horse. Okay, so let's start to look at what the direct impact of this is. So I think the first thing that comes to mind is that this begins to transform how we think about communicating ideas with machines. It opens up a very new opportunity there. It changes the lingua franca, or the language of exchange between the human and the machine, to a more human-centered one. So if a designer has a task like wanting to turn a chair into a bar stool, on the left we see something along the lines of the conventional approach that would happen in, say, a tool like Photoshop. So we have a sequence of component actions as organized by the design tool that enable us to enact this particular intent. This is, of course, somewhat arduous, even for someone who knows how to do it. And there's also a steep learning curve to understand what this sequence is. And so, even for the people who know how to do this, there's a translation of media, right? You have your idea at the level of wanting to turn the chair into a bar stool, but you have to sort of drop out of your creative intent and into the language of the tool in order to enact this sequence. And so in the process, you are sort of distracted from kind of the creative task at hand. And of course, for other people, there's no way in the first place. If instead we can begin to utilize some of the kinds of understanding of the content and the translatability between content domains that we've seen in looking at those basic architectures, we can begin to see a way of transforming how the user might communicate ideas to the tool. If the tool operates in the language of this content, then we can begin to offer features in which we do something like offer a slider to simply extend the legs of the chair. So this, of course, has a great impact in terms of who and what can happen within, who can operate within a design tool and what they can do with it. Now, this is, of course, sort of not limited to any one particular mode of input. We can instead sort of start to offer a proliferation of different ways within kind of the human-centered language that a user could begin to communicate these ideas. So, perhaps people have sort of different proclivities of how they communicate ideas, or in some cases, different types of physical limitations and strengths. So, here we see a pose model that's able to recognize the pose of the human being. And so if we're trying to, say, pose a character in an image, perhaps the most expedient way to do that would be to simply perform the pose ourselves. Or in other cases, it might make the most sense to simply offer a textual description of the object and have the generative model produce something along those lines. Okay, I think another really powerful element of what these technologies bring to design is enabling random access into the possibility space. So here we see two latent spaces, and I'm kind of using the more technical term latent space and the less technical term possibility space somewhat interchangeably. But here we see sort of two kind of simplified renditions of a latent space. And so in effect, a model like a GAN, in order to be able to produce the outputs that it does, it has to organize a kind of topology of the variability that exists within the examples that it was trained upon. And in organizing this space, it creates a kind of surface that is then navigable and also has sort of random access points. So we could drop in here and ultimately reach sort of any possible output that exists in sort of the interpretable domain of the training set. What this does at the user level is, in many cases, conventional tools have some areas of kind of the output space that are more accessible than others, either because it would take a great number of component tool actions in order to reach a particular output, or because they are simply sort of more technically involved at each of those stages. And so as a result, there's just some things that are less reachable than others. And as a result, we're going to sort of have a tendency towards people taking the path of least resistance or traveling more commonly visited destinations, more easily accessible ones. So this has the effect, of course, of kind of homogenizing the visual outputs and what people choose to say is going to be sort of in a more limited domain. In some cases, people are, of course, going to be very determined and have the desire to seek that far-reaching output, and they might be able to kind of follow the path to it. But I think one that requires the know-how to do so. It also requires the time and determination, and ultimately, it's something that, while it might happen through great determination, is not likely to happen through pure exploration and experimentation, right? This kind of very deliberate winding path is not something that you're just going to sort of happen upon. And so that barrier to exploration is a very detrimental one to the evolution of visual language. Ideally, of course, these kinds of destinations would be as accessible as any other within the space. So going further with this idea, I think the effect of this kind of ability to access the full possibility space with sort of, equal access to all points is that this has the effect of transforming design decisions to be something that is not constrained by production considerations. So for example, if we have an idea for, I don't know, a narrative of some sort where an image would make the most sense to place it in the desert, but unfortunately we don't live in the desert, we instead live in a wooded area, we can, through these tools, begin to transform that limitation and ultimately get our ideas to be exactly what they need to be, rather than what is convenient or cost-effective or accessible to us. In a related way, it opens up a new kind of access to adjacent outputs. So if, for example, we went through the process of drawing Bezier curves to define the shape of an oak leaf, and then later we think that perhaps maybe the design would have looked better with a maple leaf, while in sort of our conceptual understanding of these two entities, there is a strong resemblance. From the point of view of the Bezier curves, there's really very little in common between them. And so in order to try out the maple leaf, we effectively have to start over in our design work and redraw the curves from scratch. Where things are conceptually adjacent to one another, the tool should make them such, rather than requiring this invention from scratch. By being able to transform things in this way, we open up the ability to experiment and to try out ideas. And this, again, as per the last point, enables the evolution in the visual culture. Also, we have, like to think of it as know it when I see it, design exploration. If we ask somebody to design a living room from scratch, they probably wouldn't know where to start if they don't have professional experience in something like this. But if instead we offer them something like Pinterest to sort of open up their minds to different elements, they could begin to pick and choose pieces and put them into their living room scene. And so this kind of a sort of exploratory, know it when I see it mentality about design is something that we can engage in an entirely new way with machine learning, because we can allow people to explore this possibility space and simply try out options and see what's there. And they don't have to come with a preconceived intent. They can instead find it through the tool. That's something that's very hard to do with conventional design tools. Total control. So here we see input and output from the Spade model that I mentioned earlier. And you'll notice that there's a kind of implicitly learned physics going on here. These boulders are reflecting in the water. But of course, in that semantic input, those reflections are not drawn. This is instead taken from the training set, where essentially the physics have been learned such that the model is noticing that objects reflect in water. So from a user point of view, this is perhaps a nice thing in the sense that you get physics for free. It's kind of introduced as realism directly into the image. Of course, that's not always what you want. This kind of easy assumption is perhaps going to solve for many use cases, but at the same time, there are going to be people who want to really dig into the details and sort of add or remove any particular assumption that does or does not fit into their creative intent. With synthetic data training, we can begin to sort of permute the data set and the properties expressed in the training samples, and therefore offer to the user much more granular control of every single attribute, while still at the same time offering a sort of one-step version into it. Okay, so now looking at sort of this smattering of direct implications and direct impact, we'll now look at some of these broader implications. So creativity for all. As sort of alluded to along the way here, think that these technologies and these kinds of direct impacts are things that ultimately will enable creatives to do more and to think bigger. There's an opportunity here for users to be able to scaffold their thinkings toward ever more complex outputs and ultimately sort of transform the way that they work and the way that they scaffold ideas. Rather than being focused on component tool actions, they can begin to focus on really exacting the meaning that they are hoping to exact. And this applies to everyone. So not just elevating creative professionals, but opening the field of creative tools to a wider spectrum of people, both in terms of sort of a diversity of type of thinkers to a diversity of physical capabilities. So this is a really immense opportunity and ultimately a very cultural shifting one. And to that cultural evolution, you see, I think over time, one of the primary effects of this is going to be is a rapid transformation of visual style. The ability to sort of pull elements or attributes from kind of anywhere in the visual vocabulary and synergize them together in sort of exactly the manner that you intend is going to produce a very, very rapid acceleration of our visual discourse. It's kind of, in a sense, sort of the technology that will drive the full realization of the postmodern notion, if you will. And this will enable us to create these unimaginable realities, make them as real, and therefore sort of extend the world that we live in into something much bigger and beyond sort of the realm of the possible today. Obviously, there's a flip side to this as well. It also kind of, in a sense, means the end of photographic truth. The ability to present anything imaginable as though it were physically and photographically real also has implications in the social domain, which are of very dubious merit. So here we see a demonstration from Jordan Peele's showing of deep fakes in which he puppeted President Obama and got him to say things that he wasn't actually saying. In this kind of use case, we have a long way to go in looking at how this will be treated and how we can understand, what constitutes fact and not. I think in a related domain, you can see this as something that might produce a kind of ultimate filter bubble. So if you imagine watching a movie and saying, I don't really like this actor, I don't like their voice very much. Oh, I can just, on my remote control, change that voice or the appearance of the actor to look like someone else or look like me. This is, kind of, in a sense, an interesting property, but at the same time, it means that we can sort of personalize the media culture in ways that perhaps narrow sort of the diversity of experiences. And so there's certainly some complexity to how this is going to play out. And then, naturally, these technologies constitute the end of human creativity. No, that's, of course, not true. So I think, the cultural sphere is really the intractable simulation target. What I mean by that is, I think in many ways, the promise of AI is either has or certainly will exceed the intellectual capacities of humans by some metric or another. But when we think specifically about simulating the human intellect, I think this is a much more difficult challenge than simply exceeding it in some abstract realm. The human intellect is the product of the human life and the human experience. And so being raised in the human family, interacting with humans as a human are all very much material to the nature of what the human creative spirit is, the human mode of thought is. These are, of course, very, very difficult things to simulate. Arguably, we would need to simulate a human life for a machine in order for them to operate in the exact domain of human creativity. And so therefore, I feel fairly confident that we will remain in a realm where the creative dimensions of what comes out of design tools is still very much coming from the humans themselves. As a close friend and mentor of mine, Michael Schrage, says, making customers better makes better customers. So of course, for my work at Adobe, it would be a very foolish move for us to try to outroot human creativity. Instead, what we want to do with these technologies is to enable our customers to be able to do more, to be better designers. And I think this technology offers a really transformative opportunity for that. So I want to talk a little bit about the process of designing AI-first experiences. First, let me start with sort of an alternating definition here, defining what we call AI-infused products, or a tool whose functionality and modes of interaction were not conceived around AI capabilities, but would benefit from their inclusion. An example of this might be something along the lines of replacing content-aware fill with neural inpainting. So with a feature like content-aware fill, we can say remove a beach ball from the sand. And with this kind of content, that's going to work fairly well using a conventional algorithm that ultimately is kind of looking at textural blocks and extending them forward. We can do this with sand and the beach ball because, of course, sand is a relatively regular pattern. But if we were instead trying to fill, say, the missing mouth region of a human face, this would be a much more difficult from the point of view of a patch matching solution, because, of course, the extension of the cheek patterns is not going to lead to the production of a mouth. So if instead we can learn this over a training set with many, many examples and understand what pattern belongs in that missing region, then we can perhaps perform this task much more effectively. Of course, from a design point of view, a user experience point of view, not a lot changes here from the previous implementation. And so from a user point of view, we don't really need to worry about this. We can simply be pleased with improved results with the underlying technology, but we don't have to actually transform the way that the tool operates. And sort of in a similar realm, here show the Photoshop feature neural filters that we launched recently, where we offer a bunch of AI-based filters that can perform very complicated transformations that would take an unbelievable amount of work to perform manually. And so, in this context, we sort of take maybe, say, a half step further than what we saw with the in-painting, where perhaps for the most part, we can utilize the kind of existing interface vocabulary, but maybe in a few select ways, we start to introduce a few key mechanisms that sort of deviate from what we were used to, like, say, the introduction of the users being able to offer a reference image rather than just pull a slider. But for the most part here, we are still kind of operating in a domain where we can stay very much to the vocabulary of the tool without great transformation. An AI-first tool, on the other hand, is of course one whose functionality and modes of interaction have been conceived around AI capabilities. So this is where my team operates, and what we try to do is to look at what these technologies are and think about how to design the workflows, the use cases, the interactions, and the interfaces around these technologies and what they suggest, rather than sort of trying to retrofit them into an existing interaction model. As I said before, I'm unfortunately limited in my ability to show you precisely what this looks like today, but I wanted to sort of take you through the design process a little bit by looking specifically at some of the considerations that go into doing something like designing for latent space navigation. So here again, we have the outputs of a network like StyleGAN, and we have sort of a depiction of the latent space. So in this illustration, we have a sort of topology of variation for a piece of content, a wine glass, that in this case only has two variable attributes, the height of the glass and the width of the base. So very conveniently chosen example, of course, because in this two-dimensional interface, we have two attributes to vary. And so we can, of course, set up some very obvious and intuitive way of navigating this space, where the vertical axis represents the height of the glass. And if we sort of move our puck along that axis, we can make our glass taller or shorter. And along the horizontal axis, making the base width wider or narrower. Of course, in many cases, the content has many more attributes, many more sort of component dimensions than just that. And so we have to start to think about how to mediate this for the user. So when we sample this latent space, we have ultimately a coherent topology, but not necessarily an intuitive one from the point of view of user navigation. So if we were looking at sort of just this highlighted window of the region, we want to get to a 9. How do we do that? Well, on this top row, we can sort of start to see a bit of a leg poking out from the loop, and so perhaps that gives us a bit of an intuition that that if we go upwards, we'll reach a 9, and in fact we would be right about that. Now in this case, if we were looking for a 7, it would seem that if we go maybe up or maybe to the right, that we would reach a 7, but in fact that proves actually not to be true, right? The real region where the 7s are housed is actually up and to the left. And so this too can kind of happen in the space where we have something of a local minima that would produce sort of a distracting result and inhibit kind of an intuitive form of navigation. And then in other cases, we might just have no cues whatsoever. So if we wanted to get to a 5 from this particular window, there's really kind of no apparent guidance as to what's going to get us there. So now we begin to think, well, how can some additional interface concepts or interaction mechanisms begin to help to mitigate this particular difficulty? On one hand, we might offer something like a voice-based interface and just say, go to 5. Or perhaps we can offer something of a visual legend, which indicates sort of what direction of travel might lead us to sort of the content domain that we're interested in. Of course, when we start to sort of build out these hypotheses and test these interfaces, we have to really sort of move back and forth and kind of check the generality of what we're building, right? So, does this interaction mechanism hold up in a different content area? Perhaps here, the labeling and voice-based approach is not going to work as well because the user may not know the names of the entities represented in this space or how to articulate in a precise manner some very special attribute that they're looking for. So, overall, the way I think about this design process is to say, we start by trying to free our minds and sort of dispel ourselves of kind of the preconceived notions of, what the technology is really for or how to interact with it, and just start by playing and, consider the raw inputs and outputs of the model. And then from there, once we've really gotten a chance to sort of build up an intuition about it, then we start to think about, what mechanisms would help to make this more intuitive? How can we draw upon familiar interaction principles in iconographies, right? So, a lot of the sort of examples I've shown you here look a bit like, maps, perhaps. And, so when there is so much newness in the equation, any place where we can offer some familiarity is going to be beneficial to the user. So if we can draw upon the kind of tropes and iconographies that exist within a map, something like a Google Map interface, then we can sort of offer a user an intuitive way into this, and then they can approach all of the things about this that are new, but they are sort of tethered to something that they do understand. And then we try actually not to do this too early, and perhaps that can be sort of a shocking thing in the world of product development. But thinking about what the specific use cases are and intents, we do this once we've really started to build up some of these other points of view. But once we get there, we try to think about it in contrastive light of thinking about, is this mechanism useful for targeted search? In other words, like when a person knows exactly what they're looking for, and we're simply trying to help them find the needle in the haystack. Or alternately, is it going to be useful for open exploration when they really don't know what they're looking for and they simply want to sort of feel their way around? Or is it possible that a mechanism is going to be useful for both? And of course, what can we do to accentuate the properties that we want to bring forward for the user? Sort of more directly, the way that this kind of manifests in the work is that we sort of think, at the top level about the user interface, what this tool actually looks like. Sort of interacting directly with that is the interaction mechanisms, if you will, or things like the gesture vocabulary. So what do different touch gestures signify in terms of how we sort of navigate a space or interact with this interface. Below that are algorithmic mediations, right? So sort of things like the latent space sampling strategy, right? Like we want this topology to be sort of conceptually approachable from a human point of view. The topology from the machine learning model's point of view may be somewhat different. And so in some cases, we can use algorithmic mediation to sort of help to bridge that gap. And then of course, under all of this is the underlying model. Now, at the algorithmic level, I think what's worth noting is that this can go different ways. Sometimes what's going to make the most sense is for us to sort of bring an idea from our interactions with the model that the researchers have developed, and once playing with it, say like, well, we see kind of this other opportunity there, and if things were just a little bit different about this architecture, then that would accentuate these really desirable properties. And so in some cases, it's going to make sense to have the researchers go back and see if they can sort of augment the nature of the architecture in that direction. And in other cases, there are going to be sort of conceptual or technical constraints on the nature of the model that mean that if we want to engage this feature, we need to build those kind of algorithmic mediations on top of the model rather into the model. And so what I like to say about this is that in a lot of ways, the cutting edge is serrated. It's not a smooth blade. It in some ways is going to exceed our expectations, and in other ways is going to fall short of them. In order to bring these technologies into real products, we have to smooth that surface. And I think that this is a key piece of where design needs to engage, is to ultimately look at the nature of these capabilities and of these machine learning techniques, and to help to kind of create a smooth surface on top of them, to make them comprehensible to the user. And so I think that ultimately design is often very misunderstood in the world of technology, and this is in our work not about sort of UI guidelines and sort of putting the chrome on a fully baked technology. Instead, I think the design can play a very significant role in helping to turn a technique into a technology, right? Turning the raw capabilities of backpropagation into something which is really transformative in terms of how people can engage with it and what they can do with it. And so through all of this, I suggest that it makes sense to start to take an approach where we don't think of research as developing fully baked technologies and then shipping them over to design and product to be finalized, but that instead that there should be a very early stage collaboration between these different sides of the house. And that through this collaboration, we can begin to really connect these technologies in a transformative way. Thanks. So now I'm going to open up to questions.
Thank you, Patrick. That was a phenomenal speech. I really love the framework you shared early on about key task, operating principle, direct impact, and broader implications. That's just a really useful way to think not just about our day-to-day work as technologists and practitioners, but the impact as well. So really, really love that. I'm sure our audience enjoyed your presentation as much as I did. So we're going to be going through a few questions that were submitted when folks signed up on the Eventbrite, and then we'll go to our Slido soon after that. So let's go ahead and get started. So why do you think the topic of AI and design took a while to emerge? Like, why do you think it took a while? And then what do you think we may have missed because of that?
Yeah, I think this is a great question. I mean, I think it's only natural that the applied realm is going to be something that develops, post fundamentals. But I think specifically in the creative realm, there is a challenge that needs to be looked at from the right perspective. So I think in other realms of design, there is, in say the realm that like Autodesk is operating in, there is a path into that I think is a more perhaps in a sense natural fit for AI, right? So they've done this amazing work around constraint satisfaction, where the designer articulates, hey, I'm trying to build a bike, and what I want out of this bike is for it to be fast and lightweight. Right? And then we can bring this into a simulation space where a reinforcement agent or a genetic algorithm or something to this effect is going to try many, many variations of the attributes of the design, run it through a physics simulation, right, and ultimately produce a large number of candidates which potentially fit these attributes. Now, this depends on a sort of well-articulated constraint, and in this case, one that's really very much rooted in physics. In sort of the space of Adobe products, if we had a well-defined metric for what constitutes, say, a pretty painting, this would be also relatively straightforward to produce. But of course, that's not really how that kind of design works. And so sort of thinking about it with sort of softened edges, if you will, of sort of like kind of saying like, well, this is not about the machine doing this for us, of like just kind of, producing the amazing image that we want to see, but instead kind of thinking about, well, in this process of how the user is going to drive their own intent, what can these technologies do? And so those were kind of some of the points I was trying to make along the way of saying, how does that sort of build up? Now, naturally, there's a scale issue here, right? And I think, one thing that I had sort of wanted to mention more fully in terms of talking about backpropagation is from the point of view of like the original kind of capability, it's very difficult to see how that scales, right? Just in terms of sort of the raw capability of the hardware, right? Networks like GPT-3 and DALL-E, like these are multi-billion parameter mechanisms, right? Like the infrastructure that goes into that is immense, right? And so, if nothing else, just sort of being able to get to these kinds of complicated creative tasks has taken a fair amount of time. GANs, I think we're I think about 6 to 7 years since the original paper, and in that time, the acceleration of the sort of quality of output and just the raw pixel count of the output has accelerated tremendously. You can start to see the promise in an image that's the size of a postage stamp, but this doesn't start to really kind of transform the creative space until you hit some technical thresholds there.
Got it. Okay, no, that's really helpful to know. It seems like what you're proposing then is that our tools are not here to as critics might say, like take away, like to replace human creativity, but rather just allow for a more natural expression of it.
Exactly.
Very cool. So one of the questions was, how did your fascination or journey with AI begin? So could you tell folks, you obviously have a very multi-hat, multifaceted background. So could you share a little bit about your journey?
Sure. Yeah. It's interesting, like the intersection of sort of design and AI, I think, did not seem like the most obvious connection, at least in the world that I was operating in when I started to operate in it about a decade ago. To me, it evolved very naturally. So I did my undergraduate in philosophy, and essentially I wrote about sort of the nature of digital special effects as an artistic medium. So kind of outside of like explosions, basically sort of looking at the property of the fact that you could make something look photographic, but that you weren't constrained to reality. So it's sort of bringing together certain attributes of painting with certain attributes of photography. And I tried to sort of extrapolate forward what that meant in a linguistic sense. So when I got finished with my undergrad, I wanted to build tools that would sort of, make movies that were kind of operating in the domain that I was talking about. And very quickly, I started to see that machine intelligence was going to help with these really complicated kinds of configuration problems of if the designer was sort of trying to go for some particular set of visual attributes, how could the machine sort of help to propose those configurations? So that kind of led me to where I am now. I think, one thing I've noticed as sort of a hiring manager is interdisciplinary people are very hard to distinguish from dabblers. And on paper, these two things kind of look the same. It's hard to tell who is sort of looking at many different things and synergizing them together, and who is sort of operating in a bunch of unrelated domains. And so sort of looking back at my own career path, I realized that I certainly looked that way along the way. And so I guess my advice here would be, that one of the great things about computing in terms of democratization is there are certainly great costs to training large models, but at the same time, the ability to buy, like, I don't know, a relatively cheap computer and make something yourself and put it out into the public sphere is definitely more present than probably it ever was in history. And so that's what I would encourage is like I think the best way to present what you're capable of is to produce it yourself and put it out into the world. And so I think that's I think what I would sort of try to emphasize more in my own career if I could do it all again, to just like sort of stop doing it in my room and start putting it in the world.
Okay. Like a true artist. No, that's awesome. One of the things that we hear questions about a lot is, advice for SMEs who can't afford an AI team with regards to designing, AI products. Like, how do you suggest that, a designer can sort of get started and sort of start that journey in exploration?
Yeah, that's a great question. So, I think that so I wrote the book that you mentioned, I think 4 years ago now. And when I wrote that, I was trying to include, where do you get started with this stuff? And I think even just in those 4 years, that the availability of tools and educational materials, such as from DeepLearning.AI, that plug was not
It was
sponsored.
not planned.
I think honestly that there's been just an unbelievable transformation here, and so the ability to come from sort of different educational backgrounds and so forth into these things has been transformative. In terms of costs of training models and so forth, what I would encourage is like this discourse has happened in public in an incredible way, right? The extent to which things have been open source, the extent to which proprietary research, which frankly has had billions of dollars of investment put into it, only to have it be released on archive, right? This is just a really incredible thing, and really a transformative thing, because it means that the barrier to entry is much different from what it might have otherwise been. So I think, sort of start from what you can access in pre-trained models. And, sometimes you have to make compromises, right? When we do this stuff, like before we sort of think to retrain something, we think like, okay, well, it would be really nice for this tool to operate on every possible content domain. But that's going to take a lot of upfront infrastructural investment. What if we could sort of show this demo where, I don't know, it only works on images of birds? And like, sure, that's not going to be a full product, but perhaps you can sort of communicate what you're going for in a more limited domain and help to get to the investment, where then you can kind of build out robustness.
Interesting. So there's this concept in product management that you start with the simplest promise, that you start with the most minimum thing you want, that even when designing with designers in mind, that policy still applies. For sure.
Yeah.
Okay. So we'll turn to some questions from Slido. So Peter Lewis asks, do you have a paper where you expound on this topic? And can you point the audience to where they can learn more in depth about the subject?
Sure. Yes. Thanks for the plug.
Yeah. Wasn't me, it was Peter.
Thank you, Peter. So yeah, if you visit my website, patrickhebron.com, I have a couple papers there where I have expanded on this, and actually, a couple of the slides that I used in today's talk actually come from those. So in particular, rethinking design tools in the age of machine learning is, I think, the one that kind of most sort of focuses on on the domain of applicability to design tools per se. And then, another one, unified tool for the education of humans and machines, is sort of looking at that more from the perspective of like API development and programming tools and so forth.
Awesome. Yes. What we'll do for the audience is make sure that we link to that in the description box after the event's done, so that they can go back and listen to it, or go back and look at your site. Now, next question from Slido is, Jack here. How do you work with designers to define the parameters or the UI to give control to these techniques or get the desired output? Basically, like, how do you fit one in the other?
Yeah, let me think about this for a second. Yeah, so I mean, like to sort of give the general case is a little bit difficult. But some of what I was going for in the talk today was meant to kind of get at that. And I think, some of it has to do with like really sort of starting from kind of like what are the raw inputs and outputs of a given model. But then I think, very often, what are the abstractions that we can put on top of this, right? Like, so, the machine is going to see one thing, right? But the way that we compose that may be something very different, right? And so I think, in a lot of ways, designing for AI is really a translational task, right? You are, sort of operating very literally as the translator between sort of the realm of the human thinking and of the machine's thinking, if you will.
No, fair enough. Next question is from Jaya Vijayan. Can we create a mechanism in understanding the forward pass and back propagation dynamics to produce the target result? Essentially, can we automate the back propagation to AI?
So if I'm understanding the question correctly, backpropagation is in a sense a mechanism for automating the inductive process, right? And so the sort of brilliant innovation there, right, was to realize, so we have sort of a set of visible inputs, right, like or let's call them causes, and then we have a set of visible outputs, let's call them effects, right? And something under the hood explains those correlations between inputs and outputs, right? I don't know, like if sort of cause was that I opened my hand and effect was that a pencil, fell to the ground, right? The sort of underlying thing that explains what happened there, right, is gravity, right? So, the question in machine learning is how do we represent those, right? And of course, if you don't know what they are, they become especially hard to represent, right? Sort of the brilliant insight of backpropagation is essentially that you can treat those as a nested function of your incorrectness at the output layer, right? So if you can sort of know what you were supposed to see in some particular example, and then effectively calculate sort of the extent to which you were incorrect, you can sort of treat this as a nested function back to the inputs, and therefore kind of automate the learning of what those kind of hidden connections represent. I hope I've answered your question. Maybe you meant something different, but if so, email me.
Sounds good. So one of the next questions comes about deep fakes. And so when we had our GAN specialization launch last year, we did a launch event where we had spoken with Ian Goodfellow, and we talked about, the nature of how GANs can be used for good, sometimes in the synthesis of data and sometimes in other, fantastic use cases. Now, one of the questions from Slido is from Adil, who says, I'm worried about deepfakes. Not being able to know what's true or false can produce dangerous outcomes. How do you think the AI community can fight that?
It's a great question and a challenging one. So I think, of course, Ian is significantly more qualified than me to talk about this at the technical level. But I think, the technical challenge in spirit is that it's a game of cat and mouse, right? The generator and the discriminator effectively elevate the capability of the other. And so, sort of the better you get at producing the forgery detector in sort of a very direct and tangible way, so too does the forger become better. So this is kind of a challenging situation. Adobe and Twitter and the New York Times have sort of engaged in this thing called the Content Authentication Initiative. I think it's sometimes misunderstood as being sort of a mechanism for detecting deep fakes. Instead, what it really is sort of an authentication chain, sort of borrowing more or less from kind of the realm of blockchain. Where we say, okay, well, if we know that some particular set of pixels came out of the hardware, and then we can sort of follow this forward in a blockchain way, then we can at least say, like, here it went from this to this to this, and it say never passed through Photoshop or something like this, right? So I think that's perhaps sort of a way in. I think when I think about this stuff, I think one challenge there is a mechanism that is known to not be secure is in some ways perhaps safer than one that is believed to be, but in fact turns out not to be, right? So if a mechanism like this can be defeated, then we have potentially a very dangerous thing. I think the truth of the matter is that we are on a cultural trajectory in which it will turn out that sort of the truth apparent in photography only had something like 100 or 150 year lifespan. and that going forward, sort of photo as direct sort of evidence of reality may not continue. Of course, there were ways in which it already wasn't true, right? Just because a photograph sort of belies sort of an optical scenario, that actually exists in the world, does not necessarily mean that sort of what is implied there is sort of true in other senses, right? And so actually, photo editing has a much longer life, I think, than people realize. For example, Stalin had a picture in which he was riding a horse that was kind of rearing up. And I guess he wasn't enough of a horseback rider to manage that himself. And so in the picture, there's actually a horse trainer sort of holding the reins. But of course, this didn't look very cool for a dictator. And so that person was edited out. So at that stage in history, deep fakes existed, but they required the resources of a dictator. They've now been democratized. This, of course, has some positive consequences to democratization and, of course, some very negative ones. So I wish I could offer a better answer to what we will do with this. I think it's a very daunting thing, and it's ultimately a very transformative one. And the negative implications are certainly not lost on me. But I think the cultural discourse will play this out as much as sort of anyone involved in the technology will.
No, that's a really fascinating point. There was an era when photographs were just becoming popular, that they weren't quite mainstream yet, but people were aware that they existed, where they weren't quite yet accepted in courts of law as evidence. And so a key witness was always more powerful than a photograph in that era. And now, as we kind of move towards an era where any photograph can be, faked, and sometimes even videos, it's going to be really interesting to see how the judicial and governmental bodies really kind of handle that. And so that's a really interesting conversation, but probably for another day. And so I'd love to leave the audience with one last question, which is, what would you love to see happen in the next 10 years in the field of AI in design?
I want to see us get to a point where, where it really is sort of directly true, not just sort of aspirationally true, that the visual discourse is kind of really in the hands of everybody. I think, sort of the truth bends towards like reality bends towards justice, right? I mean, and so I think that there's an amazing transformation at play here, and we are really going to see a lot of positive things happen as a result of this. Some negative ones as well. But from creative fields to optimizing electrical grids, I think there are really transformative things happening here. And I think something that I because of sort of where I work, I don't necessarily put into my talks enough, but there's other realms of creativity that are going to be greatly impacted here. And when I look at things like what's happening at DeepMind, I think these are unbelievably transformative things that are going to engage with sort of the creativity of, say, pharmaceutical discovery. And of course, we're in a moment where this kind of creativity is going to be extraordinarily significant. So I am optimistic that while many things are going to come out of this, which are going to sort of rattle some real roots in our society, at the same time, I do think that if we all sort of mind the story together, that we will come out the other side of this with sort of a more capable and better and more just society.
No, that's a fascinating message to end on. The idea that AlphaFold is a creative tool for bioengineers as much as Photoshop is for graphic designers. I really, really love that. So that is all the time we have today. Thank you all for your great questions. We wish we had more time to answer them. Thank you again, Patrick, for joining us today. And this brings us to the end of today's event. We hope you enjoyed the event today. We're going to send up a follow email with a survey for all of our attendees. We'd love to hear about how we can make our future events better. And we're also giving a 50% discount code for any of our online courses to up to 200 people who submit qualifying responses. So keep an eye out, make sure to send in your feedback. And if you don't want to miss future events like this, sign up via the link in the description box below. And don't worry, if you can't make a live event, you can always find the recordings on our YouTube channel. So we look forward to seeing you next time. And as always, keep learning.
Thank you.